So, good day everyone. Today we will present our work on laboratory exercise 2, which involves creating a web server using our ESP32 microcontroller. These materials provided us with all the necessary tools to build and test our ESP32 web server project.
Program 3 enhances the running light sequencer from Program 2 by adding a piezo buzzer to provide sound feedback for each light sequence. This feature not only makes the light sequences more interactive but also provides auditory confirmation of the sequence selections. In Laboratory Exercise 2, Program 2 focuses on creating a running light sequencer with a web server interface using an ESP32 microcontroller. To simulate and demonstrate the interfacing diagram, we utilize the Walkwi simulator platform. Firstly, we set up a breadboard configuration to accommodate 8 LEDs. Specifically, we used 4 red LEDs and 4 green LEDs, each paired with a 220 ohm resistor to control current flow and protect the LEDs. These components were meticulously arranged on the breadboard. Next, we connected each LED to their designated GPIO pins on the ESP32 microcontroller using jumper wires. This setup ensured that each LED could be individually controlled by the ESP32, facilitating the dynamic sequencing required for the running light sequencer. This preliminary setup formed the foundation for integrating the ESP32 with a web server interface, allowing users to interact with and control the sequence of LEDs remotely via a web browser. The use of Walkwi Simulator provided a virtual environment to simulate this hardware setup and test the functionality of the running light sequencer before physical implementation. Using the interfacing diagram we prepared in Program 2, we added a piezo buzzer to complete the circuit for Program 3. The piezo buzzer is integrated into the circuit to provide auditory feedback synchronized with the running light sequences. Each of the 5 light sequences not only illuminates the LEDs in a specified pattern but also triggers the buzzer to play a corresponding tone. This addition enhances the visual effects with sound, making the sequences more interactive and engaging. The buzzer is controlled by the ESP32, with specific tones mapped to each light pattern, ensuring that both visual and auditory signals are in harmony. This setup demonstrates the ability to combine multiple sensory outputs using the ESP32, showcasing its versatility in creating rich, multimedia IoT applications. The hashtag include pitches.h directive is crucial for the functionality of the piezo buzzer. This header file defines the frequency values for various musical notes, enabling the ESP32 to generate precise tones. Each note corresponds to a specific frequency, and pitches.h maps these frequencies to note names, making it easier to write the code that controls the buzzer. Without pitches.h, we would have to manually define the frequencies for each note, complicating the code and increasing the potential for errors. By including this file, we streamline the process of programming the buzzer to play the correct tones in sync with the LED sequences. This abstraction enhances code readability and maintainability, allowing us to focus on the overall functionality of the running light sequencer with accompanying sound.
Ayan. So, yan. Hindi pa siya na-restart. So, make sure na yung baud is na 1,000, 11,550,200. So, click natin yung EN. Ayan. So, nagano na siya. Pakita ni IP address. So, let's check here sa ating So make sure nakakonect tayo sa Wi-Fi na provided ni ESP. Here. So that's my internet. So now let's connect to the group 5. Yeah, group 5. Since group 5 yung name ng ating Wi-Fi. So previously we already connected with this SSID, so the password was already saved. So let's go to the URL 192.168.4.1. So here, so ano siya. So now here is the 8 LED light with piezo buzzer. So each sequences has separate types of tune based on the code that we already provided. So here is the sequence 1. Yes, number 1. So here is the light sequence as well as the buzz sound. So let's stop. Then let's continue with the sequence number 2. So the tune is already changed. It's a different one from the previous sequence. So let's stop it here. Then let's go with sequence 4. Same with the sequence number 3 from our program 2 with additional buzz, our piezo buzz. Then next is the sequence number 4. So the buzz now it's like a beeping sound. Okay, then last sequence is the, I think something hung up. I was disconnected, so that's why the sequence 5 was cut off. So let's try again. Where is the blinking of the LED lights as well as the beeping of our buzzer. Okay, that's all guys. Thank you.